In this video, we're going to calculate tension in a rope that is moving with an acceleration. So we have a 100 kilogram block here that is suspended by a rope, and this one is in an elevator, and the elevator is descending. It's going down with an acceleration of 5 meters per second square. So we have this mass here suspended by a rope, and this system is in an elevator, and the elevator is going down with an acceleration of 5 meters per second square. So we need to find out what is the tension. It's just the weight, in fact. But how do you find out the tension here? So all we have to use is the Newton's second law of motion. First, let's write down all the known information. So the mass of the object is given, that is 100 kilogram, this mass. The acceleration is given, that is 5 meters per second square. And we have to find out the tension. And we're going to choose the acceleration due to gravity, 10 meters per second square. In fact, it has to be 9.81, but just to make life easier and calculation faster, we're going to use 10 meters per second square. First, let's draw all the forces. The weight of an object is always downward, the weight, and it is mg, that's the weight. And the tension, the direction is upward. Okay, this tension is upward here. And this tension in the rope is upward direction. And the acceleration is 5 meters per second square. So now we have to write down the Newton's second law of motion. So let's write down the Newton's second law of motion. What does the Newton's second law of motion tell you? If you remember the equation, that is F is equal to ma. And in that case, this F is the net force. So here we have the net force here. This is the net force. So all we have to write down, what is the net force acting on the object in the direction of its motion. So here I have considered the downward direction to be positive. So that means all the forces that is in the downward direction we'll call as a positive. So this direction, so we have two forces here. The one is mg and the other is the tension. So the net force would be mg minus t. Net force is mg minus t. And why negative t? Because it is in the upward direction, and I just mentioned all the direction in the downward direction is positive. So why did I choose the downward direction to be positive? And for simple reason, because acceleration is in the downward direction, and so I have chosen that direction to be positive. And in fact, you can choose upward direction to be positive, and you'll get exactly the same answer. Okay, it's entirely up to you to choose any direction to be positive or negative. So my net force is now mg minus t, and that's my acceleration ma. And we have to solve for the tension. So the tension is mg minus ma, just a basic math. And now let's plug in all the numbers here. So I have taken m out, and it will be g minus a. The mass is given 100 kilogram, g value is 10, a is 5. So if you do the math, the number you'll get is 500 Newton. The tension is a force, so its unit must be the Newton. All right, so that's how much tension there will be. And now let's assume if the elevator was not moving at all, how much there would be a tension. So in that case, if the elevator was not moving, then the tension in the rope would be simply equal to mg. And that means m is 100, g value is 10, so the tension would be 1000 Newton. And because now the elevator is going downwards, there would be less tension in the rope. Okay, and the opposite thing happens if the elevator were going upward, then you will have more tension in the rope. So this is it from this video. If you have any question, any comments, please let me know, and do not forget to like, share and subscribe the channel. Thank you very much.